Good morning, class. We're going to start with 2.1 Part A, solving one-step equations. Our objective today is to solve one-step equations with one variable. Take out a half sheet of paper for today's bell ringer. I'm pausing for you to get your half sheet of paper out. If you're having a hard time seeing this, it's on page 87 in your book. It says, the diagram shows the amount of money that each player should start with in a video game. To be fair, each player should have the same amount of money. What amount must be in the chest? How do you know that? So let's take about 2 minutes, solve that problem. Again, you're on page 87. Okay, that's time. Please pass your papers forward. While we're passing those forward, we'll go over the answer. On the left side, player number 1 has 10, 15, 20, 22, 24, 26, 27, 28, 29, 30 gold coins. Player 2 on the right side has 5, 6, 8, 10, 11. And then they have a certain amount inside that chest. How much would be inside there if they're equal? Well, to figure that out, I'm just going to subtract those two. 30 minus 11, I get 19. So let's take a look at our first sample problem here. What is the solution of x plus 13 equals 27? When we have a problem like this, it's a one-step problem. There's only one thing that we're doing. To get the variable by itself, I need to get rid of this plus 13. So I'm going to subtract 13. And the rule with this is, whatever I do to one side of my equation, I have to do to the other side. Positive 13 minus 13 gives me a 0. So it would be x plus 0, or just x. 27 minus 13 gives me x equals 14. Before we move on, though, you should always take your answer and plug it back in. Plug your answer back to check and see that you did your calculations correct. If we plug in our 14, 14 plus 13, does that equal 27? Sure does. How about this problem? Negative 7 equals b minus 3. Now, I found that a really easy way to solve these problems is to think to yourself, what number in the whole world would give me a negative 7 if I took 3 away from it? To solve this problem, I write it. How do I get rid of a negative 3? I add 3. And whatever I do to this side, I must do to this side. Negative 3 plus positive 3 gives me a 0. So it would be b equals negative 4. Let's take a look at some of these problems. The first one over here, m minus 8 equals negative 14. What number, minus 8, will give me a negative 14? Well, just like with our last problem, I'm going to add 8 to both sides. This will cancel out to a 0. M equals negative 14 plus 8. Is that negative 6? Our second problem was 1/2 equals y minus 3/2. Now don't be afraid of our fractions. It's nothing to be afraid of. 1/2 equals y something minus 3 over 2. Even though it's a fraction, I'm going to do the same thing I did over here. I'm going to add 3 over 2 to both sides to get y equals. Now, it's kind of hard to do fractions like this, so right here I'm going to write it like we would normally see it. 1/2 plus 3/2. When we add our fractions, the denominators are already the same. So we just add across the top. 1 plus 3 is 4. 4 divided by 2. Y equals 2. If I plug these numbers back in, negative 6 minus negative 8. Negative 6 minus, negative 6 minus 8. Same thing as plus a negative 8. Gives me a negative 14. 2 minus 3 over 2 will leave me with 1/2. 2 minus, if I wrote that improperly, it would be 1/2. 2 minus 1/2 is just a half. Question so far? Oh, I can't answer questions. You see what I did there? 4x equals 12. Now we're doing some multiplication. 4 times something equals 12. I think we all know what the answer is. But remember, when two things are side by side, like the 4 and the x are, that means we multiply. So to get rid of that, what should we do? 4 times what equals 12? We're going to do a little bit of division. That's okay. Not afraid of division. 4x equals 12. Divide both sides by 4. I get x equals 3. If I plug that back in, 4 times 3, 12. 2 more problems. 10 equals negative 15x. Just like the 4x, I'm going to divide both sides by something. I want to get the variable by itself. I want to isolate the variable. So I'm going to divide both sides by negative 15. Negative 15 divided by negative 15 is 1. 500 divided by 500 is 1. Justin divided by Justin is 1. Negative 10 over negative 15, that's a fraction that I could reduce. I could take a 5 out of both of those. I would get 2 over negative 3 equals x. I trust that you'll plug that back in and you can check it, but it's right. Over here we have 3.2z decimals. Are we okay with decimals? Yeah, 3.2z equals 14. I'm just going to divide both sides by 3.2. Z equals 14 divided by 3.2. And naturally, I forgot to do that. 32 goes into 140. I'm going to say 4-ish times. 4 times 2 is 8. 128, that's 12. Bring down a 0. 4 point. Let's see here. 696. I'm sure you guys all have your calculators and you're working that out correctly, right? Okay, 120 minus 96, that would be 24. Bring down another 0. And if I did my calculations correct, 4.375. Z equals 4.375. Yeah, that looks good to me. Look good to you? Okay. Row, what about division? X over 4 equals 9. Self, what number in the whole wide world could I take and divide by 4 to give me 9? How do I get rid of a division sign? I'm going to multiply by whatever's in my denominator. I'm going to multiply both sides by 4, which is the same thing as multiplying by 4 over 1. These 4's cancel out. I'm left with just the x, the variable by itself. And what's negative 9 times 4? So let's try 2 more. 19 is some number divided by 3. Well, that seems pretty easy. I'm just going to multiply both sides by 3, right? I get R equals 3 times 9 is 27. Carry the 2. 3 times 1 is 3, plus the 2 is 57. Something divided by negative 9 equals 8. Multiply both sides by negative 9. Those cancel out. X equals 8 times negative 9. Negative 72. Good. Life-changing? Life-altering math here? I don't think so. For homework, what I'd like you to do is on page 91, 11 through 35, the odd problems. Mr. Slivka, don't you know that the odd answers are in the back of the book? I do. Thanks for pointing that out, Tim. The correct answers are in the back of the book. I want to make sure you know how to do these problems. Okay? Let's get crack-a-lacking.